Hi everyone, welcome to Anna talking about organic chemistry. Instead of going direct to the functional groups and content of the organic chemistry, I will first introduce some useful tools in determining the structure of a molecule, even though sometimes you haven't seen it before or you only know the molecular formula of it. And the tool I'm going to introduce today is the degree of unsaturation, also known as the hydrogen deficiency index. As you can see from the name, there is a lack of hydrogens. In order to know the concept of the unsaturation, we will first look about the saturated molecule. What is a saturated molecule? First, it must satisfy the requirements above. No double bonds, no triple bonds, no ring structures, and let's look at some classical examples in organic chemistry. First, it is the hydrocarbons. This is the general formula. Examples are pause the video and draw the structures. Then you will discover that all of them are made of single bonds, no double bonds, no triple bonds, no ring structures. So they are all saturated. This is a saturated form of hydrocarbons. Second, I am going to talk about the carbon, hydrogen, and nitrogen compound. General formula like this. In order to demonstrate that this molecule is saturated, I draw some examples here. To compare and contrast, I also draw the mass in here. We can see as we add one more nitrogen here, we need 2 hydrogen. And here we only have 1 hydrogen. So when adding an extra nitrogen, we have to add in an extra hydrogen. Plus 1. And we can see further on, if we add 2 nitrogen, then we have still got 4 hydrogens. But we used to have 2 hydrogens. So 4 minus 2 is 2. We can see as we add in 1 more nitrogen, then we have to have 1 more hydrogen in order to be saturated. Third, I am going to talk about the carbon, hydrogen, and oxygen compound. This is the general formula of it. Examples are, and to compare and contrast again, I use a mass and molecule here. As you can see, as we add 1 more oxygen, we need 1 hydrogen, and originally we also have 1 more hydrogen, so there is no change in the hydrogens needed in order to be saturated, 0. So we can see the number of oxygens does not change the number of the hydrogen needed to be saturated. Let's look at the unsaturated situation now. The first situation is that we have a double bond. In order to compare and contrast, I draw this molecule which is saturated. In order to become the double bond, we see it discards 2 hydrogens. What about the triple bond? Again, we are looking at this example ethane. In order to become the triple bond, it must discard 4 hydrogens. Four hydrogens. What about the ring structures? Let's look at this molecule. We can see it has the formula C4H. But we know the saturated form should have ten hydrogens according to the formula of the saturated form of hydrocarbons. So we can see there is a lack of 2 hydrogens. Okay, now so what is the definition of the degree of unsaturation? It means that when it compared to the saturated form, if it lack of 2 hydrogens, then it's 1 degree of unsaturation. For example, for this molecule who possess a double bond, because it lack of 2 hydrogens compared to the saturated form, so it's 1 degree of unsaturation. We abbreviate it as 1 hydrogen deficiency index. For this triple bond molecule, we can see there is a lack of 4 hydrogens. So 4 divided by 2 is 2 hydrogen deficiency index. Finally, for the ring structures, because there is a lack of 2 hydrogens, so 2 divided by 2 is 1 HDI. Now, the basic concepts I have explained already. Now, let's look at some questions and examples that are more difficult. Let's look at some examples. All these examples are from the Chemistry Olympic of the UK. And the first question is that the general formula for an acylic alkane is CnH2n plus 2. Give the general formula for the formulae. An alkane or a cycloalkane. An alkane means there is a double bond, so there is a lack of 2 hydrogens. A cycloalkane means there is a ring structure, so there is also a lack of 2 hydrogens. So the general formula should be CnH2n. Let's look at another. An alkane. We know there is a triple bond, so there is a lack of 4 hydrogens, which means the general formula is Then let's look at the third example. Cycloalkane means there is a double bond and a ring structure, so there is a total lack of 4 hydrogens. A dialkane means there are 2 triple bonds, which means there is a lack of eight hydrogens. The second question is a little bit difficult, which is to determine the number of double bond equivalent in those molecules. Remember that the double bond equivalence is the same as degree of unsaturation, which is equals to HDI. Look at this formula, C5H4. We know its saturated form should be so the degree of unsaturation should be four. The same applies to this molecule. Its saturated form is so the degree of unsaturation is the rule also applies to this molecule. You might be a little bit confused, but just apply the rule to it. You will get the correct answer. Its saturated form should be however, there is no hydrogens here. So there should be 61 degree of unsaturation. Next, look at these ring structures. We can see there is 1, 2, 3. 3 double bonds. And don't forget about the ring structures also present. This is a ring. So there is total 4 degree of unsaturation, also abbreviated as 4 HDI, as one double bond consists of 1 degree of unsaturation and one ring consists of 1 degree of unsaturation. Look at this molecule, we can discover that there is a triple bond and a double bond. And don't forget about the ring structures. So we know for each triple bond, there is a 2 degree of unsaturation. For a double bond, there is 1 degree of unsaturation. For a ring, there is also 1 degree of unsaturation. So the total should be 4. Look at these structures, you might be a little bit confused. Yes, this is a very magical molecules because it's similar to a part of the diamond molecule. You can search this on your own and you can discover many magical properties of it. Then I'm going to look at its degree of unsaturation. And how to see molecule like this is a bit complicated, but tell you a method is that how many cuts you need to make in order to let this molecule be linear. We can see if we make 1 cut, there is still 2 rings present. So it's still not a linear structure. But when we make 2 cuts, we can see there is still a ring structure present. So it's still unsaturated. Let's make a further cut. Now we can see it is a linear structure, so there are a total 3 ring structures present. So there is 3 HDI. And if you want to prove this is true, you can use another method by counting the carbon and hydrogens on it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30, 40, 50, 60. And compared to the saturated form, we can see there is also 3 hydrogen deficiency index, so we can use this to prove it. But as we see that counting actually is very time consuming, and sometimes you get yourself confused about it. So this method actually is quite simple and easy to understand, and you cannot make some mistakes about it. Now is the final part. I want to give you guys some testing skills when you are doing in a competitions. First, if you see 4 degree of unsaturation, I want to remind you guys that it may be a benzene ring present. This is a quite common testing skills you should get, because benzene ring have 3 double bond and ring structures together. There are 4 HDI, and another interesting molecule that is not tested so usual but is fun to look at, it is the big structure. Yes, this is not a mass problem, it's a molecule actually. And it asks the formula, which means it has it has 5 HDI because it has 5 ring structures.